So yesterday we have discussed what is server virtualization. Let's proceed and discuss the remaining few topics on virtualization. So there are two approach of virtualization. When we talk about a virtualization, there are two different approach for virtualization. One approach is virtualization management layer, and another approach is dedicated virtualization. There are two approach. One is virtualization management layer. Another one is dedicated virtualization. Now consider you are having a laptop which has 16 GB RAM, i7 CPU is there in your laptop, and you have 500 GB hard disk, or now it's SSD. So let's say you have SSD. So let's say you have this configuration in your laptop which you have bought from the market, and on the top of it you have installed Windows 11 operating system. So this configuration is for your laptop which you brought from the market, and it has Windows 11 operating system installed. All of the sudden you realize that you are using only 10% of this total resources. you, Whatever configuration you have on your laptop, you are using only 10% of the resources, and the remaining 90% of your resources is of no use for you. Remaining 90% is of no use for you. It is getting wasted. So now, being a technical guy, you will say that I have done such a huge investment and I am not even using the full resources. So remember, there is a software which is very commonly available in the market, and many would have used in their college life as well when they were learning at that time, and everyone is familiar with this software, which is VMware Workstation. This is from VMware. This software is built up by a company, VMware. Similarly, if you talk about Microsoft, they have their own virtualization software, Virtual PC, with the name Virtual PC. Similarly, Oracle has their own software with the name Oracle Box. Now, what you can do, you can simply install the VMware Workstation or Virtual PC from Microsoft or Oracle Box from Oracle. You can simply install this software on your laptop. What you are going to do is you have your laptop with you now. Let's say, for example, this is your PC or a laptop which you have. Okay, and then what you are going to do is in this laptop, let's say you have bought a laptop, and in this laptop you have installed Windows 11 operating system. This is your laptop, and in your laptop what you have done is you have Windows 11 operating system installed. So what you are going to do is you will be downloading the VMware workstation from the VMware website, and over here you are going to install this application. What is the name of the application? It is VMware Workstation. VMware Workstation. You are going to install this software VMware workstation on your laptop. And inside this application, VMware workstation, you can install virtual machines. You can install virtual machines. So you can install multiple virtual machines. It can be your Windows VM, Windows virtual machine, or it can be your Linux operating system of any flavor. This you can do. Voice is breaking. Is it clear now? Am I perfectly audible? Please confirm in the chat box. Am I audible now? Please confirm in the chat box. That's great. So what we have discussed is you are having a laptop with a high configuration with Windows 11 operating system installed. Now you have realized that you are only using 10% of your resources, whereas 90% of your resources is being wasted. It is of no use. And we have discussed that there are virtualization software coming from different OEMs. If it is VMware, they give VMware Workstation. If it is Microsoft, they give Virtual PC. So they have their software. Oracle has their own software with the name Oracle Box. So now what you did, you have on the top of the Windows 11 operating system, you have installed a software with the name VMware Workstation. Now, if you have installed the software, it allows you to create virtual machines inside it. So you can install multiple virtual machines within this VMware workstation. It can be Windows operating system, Linux operating system, or any other operating system using the free available space. So now when you are installing this operating system inside your VMware workstation, resources like this is Windows operating system, Windows virtual machine, and you will be allocating the RAM, you will be allocating the CPU, hard disk. So from where you will be allocating? Actually from the laptop, the physical hardware. Similarly, for Linux operating system, you will be allocating the resources, that is RAM, CPU, hard disk, from the actual physical hardware from the laptop. So these virtual machines will be utilizing the resources from your physical hardware, that is your laptop. Is it clear? So, can I say that using a single PC, I am doing efficient utilization of my resources? Using the single laptop, I am efficiently utilizing the resources. The 90% of the resources which was wasted earlier, now I have created this virtual machines and I am using it for different tasks. So I am efficiently utilizing the resources now, and my resources are not getting wasted, or it is the wastage is being reduced up to some extent. So such kind of virtualization is called as virtualization using management layer. The first one, the first of the first type, virtualization management layer. This type of setup, when you have your physical hardware and you are using you're creating a virtual machine using VMware workstation, such kind of setup is called as virtualization using management layer. So in management layer virtualization technique, your virtualization software, meaning your VMware workstation software or your virtual PC software or your Oracle box software, whatever virtualization software you're using, your virtualization software is dependent on your host operating system, right? Windows 11 is a host operating system. Your laptop is having Windows 11 installed. So your VMware workstation is dependent on your host operating system. Your virtualization VMware workstation is dependent on your host operating system, that is your laptop operating system, which is nothing but Windows 11 in our case. And I can say that this operating system, Windows 11 operating system, is actually managing the virtualization software. Right or wrong? Your Windows 11 operating system is managing your VMware workstation, that is your virtualization software. So now let's say that if you have Windows machine, which is Windows 11 in our case, we have Windows 11 operating system over here, and due to some reason, this machine goes into hang state. This machine is no more functional. It has gone into the hang state, Windows 11 operating system. So now, in this scenario, if there is an issue with the Windows and there is no solution or workaround, what you are going to do is you will restart, right? You will restart. So now just consider that if you restart your laptop, meaning all your virtual machines which are running in the VMware workstation will go down. It will go down because your VMware workstation is dependent on your operating system, which is nothing but Windows 11 in our case. So if you restart your laptop, all your VM inside the workstation will go down. So this kind of virtualization is good. This kind of virtualization technique is good, where you install a virtualization software to create the virtual machines on your existing hardware for testing purpose. If you are doing any kind of testing, so what you can do, you can just install the VMware workstation. Inside that, you can create virtual machines and you can perform your testing, and it is good. You can do a testing at a very cheap not even cheap, I can say at free of cost. You can do such kind of testing. But remember always that this kind of technique, virtualization management layer technique, or when you are doing the when you're installing VMware workstation on your laptop or your PC, always your virtualization always is dependent, all your virtual machine is dependent on your physical host operating system. Everything is dependent on your OS, which is Windows 11 in our case. So if the Windows 11 get crash or it goes down, everything will go down. All the virtual machines will be no more accessible. So I can say that this can be used for testing or R&D purpose, but it cannot be used in data centers. The actual setup. Voice is breaking. So is it still breaking, or please confirm if it is back to normal now, or it is still breaking? The voice is breaking still. Yes, please confirm if it's normal now or it is still breaking the voice. Okay, it's good. So this can be used for testing or R&D purpose. This kind of virtualization approach can be used for testing or R&D purpose, but it cannot be used in data centers. When we talk about another approach, that is dedicated virtualization, right? Another approach is dedicated virtualization. So when we talk about dedicated virtualization, so consider over here, there is no OS installed. Okay, no operating system is installed on hardware. There is no operating system installed on hardware. Yesterday we have discussed about hypervisor and all, right? ESXi, what is the server virtualization? We have discussed in short. So have I mentioned anywhere that there is any operating system installed? No. So in this approach, you cannot install you cannot install Windows or Linux. Why? Because this Windows and Linux are general purpose operating system. This Linux and Windows are general purpose operating system. When we talk about a proper virtualization technique, what you have to do, we have to get VMware vSphere from a VMware. We have to get VMware vSphere from VMware. You need to approach to VMware and you need to request for a specialization software which is VMware vSphere. You will ask them for VMware vSphere solution. So when you VMware will give you, when you go to VMware and ask for VMware vSphere, VMware will give you a bare metal hypervisor. Bare metal hypervisor. That is type 1 hypervisor. It is also called as type 1 hypervisor. Bare metal hypervisor is nothing, or type 1 hypervisor is nothing but an operating system dedicated for virtualization. And bare metal hypervisor or a type 1 hypervisor, and it is called as VMware. In VMware, it is ESXi. When we talk about bare metal hypervisor or type 1 hypervisor, in Oracle, it will be different name. In Microsoft, it will be with a different name. But over here in VMware, it is called as ESXi. So what is ESXi? Again, it is an operating system, but for special purpose, not like Windows or Linux, which is used for general purpose. It is used for special purpose, and this ESXi is dedicated for virtualization. Since it is dedicated for virtualization, it is also called as hypervisor. So remember, remember the OS is dedicated for virtualization. The ESXi operating system is dedicated only for virtualization, and this is a reason it is called as hypervisor also. And this ESXi is very robust and a reliable operating system. It is not like Windows. ESXi is very robust and reliable operating system, similar to installation of Windows and Linux. Like in Windows or Linux, if you want to install, what you need ISO bootable image, right? You need ISO bootable image. So we can install ESXi on the hardware. Similarly, we can install ESXi on the hardware. Such installation is also called as bare metal installation, which we have discussed sometime before. But there is a difference in both this operating system. When you talk about VMware and general purpose, that is Windows or Linux, there is a difference. See, in Windows operating system, what you can do, you install a Windows operating system, and on the top of it, what you are going to do is you can install multiple applications. You can install Google Chrome, VLC Media Player. You can install antivirus. You can install Mozilla Firefox or Microsoft Word, PowerPoint, many applications you can install. But this is not the case with the hypervisor, or in VMware it is ESXi. This is not the case. Once you have installed the ESXi, you cannot install any application. It will allow only you to create the virtual machine. It will allow you to create only virtual machine. You cannot install any unnecessary application on it. Why? Because ESXi is dedicated for virtualization. Any questions over here? Any doubt, or we can proceed further? So hope you understood the different approaches and their limitations as well. Now, moving ahead with the discussion, what we are going to discuss now is, we have already discussed yesterday about the server virtualization, right? Who can learn server virtualization? Now, virtualization is fundamentally better. What does it mean? What does it mean? Consider, consider you have a very high end hardware with you. You have a very high end hardware. You have brought hardware from HP or a Dell or IBM, whatever OEM it is. You have brought an high end hardware, and now this hardware is just nothing but a server which you brought for your company. Now, what you will do? You are looking for virtualization. So you will go to the VMware website. Okay, you will go to VMware website and you will look for vSphere. So when you ask for VMware vSphere to the VMware, they will be giving you a hypervisor, which is nothing but ESXi. They will be giving you the hypervisor, which is nothing but ESXi. And you all know that this hypervisor ESXi is dedicated for server virtualization. We have just discussed sometime before that when you have a general purpose operating system, it is Windows or Linux, you can install multiple applications on the top of it. Why? Because it is for general purpose, general operating system. But remember, in ESXi, it is dedicated only for server virtualization. So you cannot install any software or anything. You can only create the virtual machines on the top of it. And when you talk about ESXi, remember it is a very lightweight hypervisor. ESXi is a very lightweight hypervisor of the size around, I can say, 385 MB. And amongst this 385 MB, I can say that the actual operating system size is 180 MB, and the remaining 200 MB is the VMware tools actually. So what is VMware tools? It is something like your Windows drivers. Like in Windows, you have drivers and all, right? So it is something like drivers, and then there is nothing but called as VMware tools over here. And remember that this VMware vSphere, it is one of the most robust and a reliable operating system in the cloud operating world also. Even in the cloud, the backend is VMware. So let's discuss about VMware vSphere history, the evolution of the VMware vSphere to understand more. Now, just for your information, earlier days, the product was not known as VMware vSphere. The name of the product was the name of the product was VMware Virtual Infrastructure Suite. The name of the product originally it was VMware Virtual Infrastructure. And remember that the first product of VMware, the first time the VMware was launched in the year 2001 with the version virtual infrastructure VI 1.0. And at this time in 2001, it was not so much popular. It was not so much popular, but the product gained much more popularity in the year 2008. The product gained much more popularity in the 2008, and at that time, the version was virtual infrastructure 3 and 3.5. Then the name got changed from virtual infrastructure. The name got changed, and the product came with the name vSphere version 4. That is vSphere 4 in 2009. Then vSphere 5 came in 2011. vSphere 6 came in 2015. Then vSphere 7 came in the Corona year, that is the year 2020. Now we have vSphere 8 in the year 2023. So this is how the vSphere, the virtualization product from VMware, got its popularity and it got enhanced Recently, it is acquired by a company called Broadcom. Now, moving ahead with the discussion, if you talk about the older versions, that is up to version 3, that was in the year 2008. Before that, in the older version, what was the product, what was an operating system name? It was only called as ESX. It was called as ESX in the older versions. It was called as ESX up to version 3. But then thereafter, we got, when we were buying VMware vSphere, we used to get ESX as well as ESXi. We were getting both these options. And then what happened in the year 2011? I will tell you what is ESX and what is ESXi, the difference, everything I will tell you. But for now, just remember this. In 2011, vSphere 5 was launched. vSphere 5 was launched, and the product was sold with only ESXi. Is it clear how the evaluation, has happened for this product VMware vSphere? Earlier it was called as virtual infrastructure. Now it is called as vSphere, and how the evaluation has happened. Everything is clear. Now let's understand one topology. Whenever you will listen about this, you will always have something called, know, you will be always having something called ESXi. Whenever you say ESXi, it will be ESXi host, and whenever there is virtual machine running on the top of this ESXi host, it is always termed as guest operating system or guest VM. Why it is so? Why it is so that ESXi, this you can see over here, you have a ESXi host, right? Say this is your ESXi host, this is your ESXi host, and this is your ESXi host. This all are nothing but your ESXi host. These are nothing but your ESXi host. Always you will listen the word ESXi host, ESXi host. And if you will see over here, if you will see over here, you have virtual machines running, you have virtual machines running over here, you have virtual machines running over here. So in general, you will always listen a term saying that this is nothing but guest operating system. We need to understand why it is so, why it is termed as ESXi host and guest operating system. So now consider that you have arranged, you have some function at your home, okay? You have some function at your home, and you are hosting a party. Since you are hosting a party, so you will be called as a host, right? Now, since you are hosting a party, it can be a birthday party or a wedding party, whatever it is. So it is your responsibility, right? Since you are hosting a party, it is your responsibility that you have to arrange the food, you have to arrange the meal, you have to arrange all other necessary requirement whichever is required for the guest to whom you have called. It is your responsibility that you have to arrange the food, the drinks, everything you have to arrange in the party, right? Because you are the host. Now, to whom you have called in the party are called as guest, and you will be allocating the resources in the sense you will be giving them food, you will be giving them drinks. So it is a responsibility of the host to give the drinks, to offer the food, everything you will be offering to the guest coming. In a similar fashion, if you will see over here, this hardware, the physical hardware on which the ESXi is installed, it has all the resources. This hardware has the RAM, this hardware has the CPU, This hardware has the hard disk, everything is there. Now when you're creating the virtual machine, you it's the host responsibility to allocate this RAM, CPU, hard disk on this virtual machines, right? This is the reason it is called the guest and this is the host. Is it clear? Is it clear why this is called as host, ESXi is called as host, and why the virtual machines are called as guest? Now, what exactly happened over here is when you are looking for the virtualization of your when you're looking for the virtualization, well, the very first thing what you're going to do is, as soon as you have the hardware with you, as soon as the hardware is available with you, as you can see over here, this is nothing but the hardware. As soon as you have the hardware available with you, on this hardware what you are going to do is you will be installing the hypervisor, which is ESXi. You will be installing ESXi. To install ESXi, we need the hardware, and the installation is very simple. Remember, the installation is very simple, and this installation can be completed within few minutes. Once the installation is done, the very first thing what you are going to do is, once the installation is completed on this, the ESXi is installed. First thing what you are going to do is you will be configuring IP address and the password you will be configuring for this ESXi server. Okay. Once this is done, the IP address is configured. You have set up the password. Now see over here also CCNA is required because you need to configure the password. Then you have to do the net. You have to configure the IP address. Then you have to do the networking. So CCNA is that much powerful. Without CCNA, you cannot do anything. CCNA is a basic. Now, once this IP address is configured and the password is set, what you are going to do, the next step is that the machine will be kept in the data center and you can access this machine. You can access this hardware, this server through web browser. You will go to web browser and you will be accessing it. And now assume that over here in the screen you have three ESXi hosts. So you will open a browser. What you're going to do is you will open a browser, and in the browser you will be entering the IP address. In the browser you will enter the in the browser you will enter the IP address. And once you enter the IP address, this ESXi host will be accessible, right? Now, if you want to access all these three ESXi hosts, what you will do, you will open new tab. In the new tab, you will put the second ESXi host IP, and then in the third tab, you will put the again one more ESXi host IP. But consider you are having 100 or even more of ESXi hosts. Now over here in this case, three were there. What you did, you have opened new tabs and you have entered the IP address. You have accessed the ESXi host. But consider a scenario where you have 100 of ESXi hosts running in your environment. So will you open this 100 tabs in your browser to access the ESXi one by one? Yes or no? Please put in the chat box. If you have 100 ESXi hosts running in your environment, will you open 100 tabs and you will put one by one IP address and access this ESXi host? No, because it will not work. So you must have some solution where you can have a centralized management of all this. So there should be some method, right? And the method must be something like centralized management, where you can centrally manage all the CSSI hosts. So there should be some method. A centralized management should be there. So VMware says that we have a server called vCenter server. There is a server called as vCenter server. You can see this vCenter server. VMware says that we have a server called vCenter server. This vCenter server is an application server. It is an application server, and benefit of this server is no need to install this server. You don't have to install this server. No need to install any operating system. This server is directly available as a vCenter appliance. You don't have to install any operating system. Then on the top of it, you have to install some application so that your vCenter server will work. No, no, no. This is not the case over here. There are some benefits. What you have to do, you have to go to the VMware website and you have to simply install this vCenter server appliance. It means that you have a ready-made operating system with application installed. When you download the setup, when you download this vCenter setup, you will see that it is a ready-made machine. It is a ready-made machine. It is a ready-made machine where OS with application is already installed. It is a ready-made machine. It is a ready-made OS with application automatically installed. So what you have to do is simply you have to go to the website. You have to download the vCenter server appliance virtual machine. Now this is a simply an introduction, and we will be having an overview only over here. If you need to have a detail, then you have to join VMware vSphere course at Node Networks, and you will get the complete syllabus over here. Now consider we have this one server, vCenter server we have over here. What we will do, we have downloaded and installed this VMware vSphere server, and what we are going to do is the very first thing. Similarly, we will be setting up the IP address for this server. We will be setting up the IP address. Along with the IP address, you will set username, password for this server. Then you will open the web browser, and in the browser we will put the vCenter server IP with the credentials, and you will see that the vCenter server console is open for you. Now over here what we are going to do is, once you have access the vCenter server, here in the inside this vCenter server, one by one we will be adding the ESXi host. You can see that scenario over here also. This is one. You will see that this is your one ESXi host in which you have multiple machines. This is your ESXi host in which you have multiple virtual machines. Then this is your ESXi host in which you have multiple virtual machines. One by one you will be adding this ESXi host in the vCenter server. So in short, this vCenter server can manage ESXi servers. And for your information, this vCenter server in version 8, which is the latest version of the VMware, it can manage up to 2500 ESXi host. It can manage up to 2500 ESXi host. Any doubt, any question over here? Now, going ahead with the discussion, remember, whenever you want to use, see, there are many features in VMware vSphere. There are many advanced features which we are going to discuss in short one by one, and we will understand the beauty of the product. But before that, remember that whenever you want to use the advanced feature of VMware, There is one requirement. There is one requirement. Whenever you want to use the advanced feature of the VMware, there is a requirement. There should be a shared storage. As you can see over here, as you can see over here, this is one ESXi host with the virtual machines running on the top of it. Then you have this ESXi host running virtual machines. Then you have this ESXi host running virtual machines. But over here, you will see that all these machines are connected to one storage over here. If you can see, this is one storage, and this is a common storage. This storage is connected to all the ESXi hosts. So if you want to use the advanced feature, which we are going to discuss in the coming time one by one, you require a shared storage, a common storage. Why VMware is advanced virtualization platform, you will realize when I'm saying that VMware is a very advanced virtualization platform, and when I'm saying that VMware is an advanced virtualization platform, you will realize by understanding its feature one by one. We are going to discuss about the feature one by one, and you will realize that why it is important. So we will just have a general overview of this feature, but in the coming, but if you are taking the course from the new networks, you will have a detailed discussion and a hands-on lab for each and every feature respectively. So any doubt, any question till here? Okay, so let's start discussing the feature overview one by one. Okay, now let's assume a scenario that in my environment, I have an environment where I am running three ESXi hosts. I have three ESXi hosts running in my environment. Okay, I have three ESXi hosts running in my environment. ESXi one is there, ESXi two is there, and ESXi three is there. I have three ESXi hosts running in my environment. Okay, I will just name it. It is ESXi1, and then this is something ESXi2, and this is something ESXi3. I have three ESXi hosts running in my environment. Okay, and then on this TSSI host, as I told you that use the advanced features, we should have a common storage. So let's assume that there is one common storage available. There is one common storage available. This is nothing but a storage available. And on this ESXi host, on the top of this ESXi host, you have this small, nothing but a virtual machines. You have virtual machines running on the top of it. Okay, just consider that I am getting an error from one of the ESXi host. From, let's say, from ESXi one host, I am getting some error saying that one of my power supply of this ESXi host is faulty, or let's say it has some motherboard issue. Physical hardware ESXi one has some issue. So just if in case the one of the ESXi host goes down, then what will happen? All this virtual machine should go down, right? But VMware says that don't make it down. What you can do is you can simply transfer this machine, whatever machine are running on ESXi 1. What you can do is you can transfer your virtual machine live to another ESXi host. It can be ESXi 2, it can be ESXi 3, and you have a common storage. Huh? So storage remains same. This feature of live migration is called as vMotion. This is called as this live feature is nothing but called as vMotion. Not automatically, you will go to the faulty SSI. It is not happening automatically. This vMotion is not happening automatically. What you will do is you will go to the faulty SSI host, that is ESXi1 in our case, and you will migrate this machines to another ESXi host. You can migrate this machine. This machine is the right. This is a faulty machine. You can migrate this machine ESXi2. You can migrate this machine to ESXi3. And once this machine is migrated, although the storage is going to remain same. Why? Because the storage is the shared storage. So the machines are migrated. The machines storage was over here in the common. It is attached to ESXi2. It is attached to ESXi3. Storage will remain same. So what will happen? These machines are migrated to ESXi2, ESXi3. The storage is same, so these machines will keep running. Before it was running on ESXi1, but using a vMotion feature, you have migrated to ESXi2 and ESXi3. This machine was sharing the common storage. The hardware was sharing the common storage, so this machine will keep running on ESXi2 and ESXi3. How it will happen? This is something we will be learning when we will be doing when you join the VMware course at Noon Networks. At that time, you will learn this in detail, but this is general overview. And this is the reason you need to have a shared storage, which is very important to use the advanced feature like vMotion. Now all your VM virtual machine running in the faulty hardware is moved live to ESXi2 and ESXi3, another hardware. So now you can make your faulty hardware for maintenance or replacement without any impact. So this is nothing but a feature called as vMotion. Similarly, there are many advanced features in VMware workstation that are storage vMotion. Then we have distributed resource scheduler, which is one of the advanced feature, and it is also known as automated virtual motion vMotion. Automated vMotion. Then you have high availability feature, fault tolerance feature is there. So, in short, I can say that if you are joining the VMware Register course at No Networks, you will be able to perform the hands-on lab in detail understanding at expert level on VMware vSphere. Now, again coming to the topic of the CCNA, which is our actual topic. This was a bonus lecture for you. Now, we will be starting with the CCNA topic, which is Mac learning and aging. We will move ahead and discuss about frame switching, frame flooding, MAC address table, and directly we'll move to one of the very hot topic and a very important topic, that is VLAN, which is going to be started in the next week. Let's start with MAC learning and aging now, and we'll understand this concept. Before that, what I want everyone to do is open your packet tracer. Open your packet tracer. If everyone has opened the packet tracer, please confirm in the chat box so that we can continue further. Be quick. Okay. Simply what you have to do is, over here you will see network devices, right? In that you will see router. The second is switch. Just drag one switch over here. Drag one switch over here. Okay. And then you will find on the top over here you will have end device. Click on the end device and take two computers over here. Computer 1 and computer 2. Take these two computers. Now what you do is just come over here to the connections and take the automatic cable over here. Click over here and just connect this one cable over here. Again take the cable and click over here. Connect this cable also over here. You have connected two PCs to one switch. You have just will change the name and will give it as PC1, and we will change the name this PC, we will say this is PC2, and this PC we will change the name to PC1. And just ensure that you have connected one port to fast Ethernet 0 by 1, another to fast Ethernet 0 by 2. Everyone has done this. If everyone has done this, what you do is just open this PC1 over here, go to desktop, and then go to IP configuration and give the IP address of the PC as 192.168.1.1. and close it. Come to PC2, go to desktop, go to IP configuration, give the IP address as 192.168.1.2, subnet mask value 255.255.255.0 and close it. Everyone is there with me? Everyone has completed till here? Remember, we have not touched the switch now. We have not done any configuration. We have not understood anything on the switch. But for doing this practical, just whatever I'm doing, do it. Later on, I will teach you what exactly is done. You will understand also what exactly is done and what is going on. But for now, what you do is simply click on the switch and go on CLI. Whatever I'm doing it, just do it. Later on, I will explain you. But for now, just click on the switch, go to CLI, hit enter. Okay, and minimize this. Open PC1, go to command prompt and minimize it. Over here also, go to command prompt for PC to minimize it. Everyone has done this. Now over here in this topology, what we are going to do is we will be pinging PC1 to PC2 and we will understand what we are going to understand. We are going to understand how this Mac learning take place, what is aging. This we are going to understand. Now simply what you have to do is you have opened the command prompts, right? Come to PC1, come to PC1 command prompt. And what is the IP address of PC2? 192.168.1.2. Ping over here, ping 192.168.1.2. For everyone ping reply is coming. You went to PC1 and you try to ping 192.168.1.2, which is the IP address of PC2, and you can see the ping reply is coming. Moreover, if you want, just you can say -T for continuous ping. Okay, just leave it. It's not working for some reason. We don't have to see that also, but everyone has, and the ping reply is coming, right? Please confirm in the chat box for everyone ping reply is coming, or is there anyone left for whom the ping reply is not coming? That's coming for everyone. That's good. Now, from here, open the console of the switch. Okay, just type en. Sorry, just type en. What is en? What is there are modes of switches. This everything we will learn. Don't worry, we will learn everything. But for now, just what I'm doing, do it blindly. I will teach you everything. Give the command over here. Show Mac. Sorry. So show Mac address table dynamic. Everyone give this command. Show Mac address table dynamic and hit enter. Everyone is able to see this. The entries are there and the type is written dynamic. It is also the MAC address is written and from which port the switch has learned the MAC address, that is also written. The meaning of this is a MAC address. It is learned dynamic and it has come from port number 2 of the switch, which is PC2. And there is one more MAC address which is learned dynamic and the switch has learned from port number 1. What is the timing on your PC? Just carefully note that and leave it for now. Everyone has done it. Confirm in the chat box, please. Okay. If everyone has done it, now let's discuss what we have done. We'll understand that. So we are going to discuss Mac learning and aging, meaning that how the Mac is learned by the switch and there are some aging timer. How long we have seen that entry which is learned dynamic. How long that the what is the age of that? That everything will now learn. Everyone knows that MAC address is a layer to address. In OSI layer, It is layer 2. Switch works on layer 2. This also we have discussed when we were discussing about the OSI. At the same time, we have learned that MAC address, which stands for Media Access Control address, is a 48-bit physical identity of a device. It's a physical address. Actually, it is on the network card, right? It is a physical address. So it is a 48-bit physical identity, or you can say it's a physical address of a network device. We have also discussed that it is a layer 2. It uniquely identify a device in layer 2 of the OSI model. MAC address identify the device on the layer 2 of the OSI model. We have discussed that it is represented in hexadecimal format. This also we have discussed. We have also discussed that it is a six six byte address, right? This is a 6 byte address, or you can say that it's a 48-bit address. This is all we have discussed. We have also discussed that 3 bytes of the MAC address represents the OUI, and 3 bytes are unique to the device. Everyone remember this. We have discussed this, right? What is OUI? Yes, anyone can tell what is OUI? What is OUI? Organizationally unique identifier. So we have discussed that the IEEE, that is Institute of Electrical and Electronic Engineers, manages the first 3 bytes. It is assigned from the OEI to the organization. Like let's say, for example, if Cisco want to build up their NIC card, or the Microsoft want to build up their NIC card, whoever want to build their NIC card, they will approach to OUI, and OUI will be assigning the first 3 byte, which will be unique for each organization. Let's say, for example, if it is Cisco, you will see that all the Cisco cards, if it's starting, the starting 3 bytes will be same, but the remaining 3 bytes will be unique. It will be different for each and every device, and this is how the uniqueness of the Mac devices are maintained. This we have discussed when we are discussing about OSI. We have discussed. Anyone has any questions over here? No questions, right? Now, what is Mac learning? Mac address learning. What happened? See, switches works on MAC address. Switch is a layer 2 device, and you know that on layer 2, MAC address works. So what happened? As you can see over here in our scenario, you have connected two PCs, PC1 and PC2, right? Always remember that switch learns the MAC address. Switch stores the MAC information. Switch stores the MAC information. This switch is there. Will store the MAC information. Just now, sometime before, we have seen this, right? There is a MAC information over here. You will see that there is a MAC information over here. So what switch does? Switch stores the MAC information, the MAC address information, in a table. This is a table, and you know what is a table name? It is a CAM table or the MAC table. It is also called as CAM table or MAC table, content addressable memory table, or MAC table. The table which you have seen after you have given the command show MAC address table, you have given this command, right? Who's okay? Show MAC address table dynamic. So this table is called as CAM table or MAC table. So what it shows? If you will see over here, the CAM table or a MAC table stores the MAC address. See, this is a MAC address. It stores the MAC address, right? It stores the interface details from which interface this MAC address is learned. It stores the VLAN information. What is VLAN? We will discuss in the next week. It stores the VLAN information, and it tells you how the MAC address is done, whether it is done statically or it is done dynamically. So, what the MAC table or a CAM table have? The very first thing, remember, switch learns the MAC address from the frame. Frame means as soon as there is some information, it creates a frame, which this we have learned in our initial lecture, right? So switch will learn through the MAC address. Then what switch does? As soon as something some MAC address hits on the port, switch stores that MAC information in the CAM table. Now PC1 have ping, so it stores the information. How the information is stored, what the CAM table contains, or what the MAC table contains. It contains the MAC address. You can see over here, it contains the MAC address. It contains the interface information. Then it contains the VLAN information, and it says that how this is learned. It is learned dynamically or it is learned statically. This all information is being stored. Okay. Now, what happened when PC1 tries to ping to PC2? Okay, meaning that when PC1 says ping this, so at that time the frame is created. Everyone knows how the frame is created, right? Everyone knows how the frame is created. It contains source MAC address, it contains destination MAC address, source IP, destination IP. So whenever the frame hits the interface, this frame is created over here and it hits the interface, or the interface of the switch. That is, in our case, it is fast Ethernet 0 by 1 over here. So what this switch do? What does this switch do? As soon as the frame hits, what this switch do? This switch is there. What does this switch do? The switch first checks the MAC address. It will check the source MAC address. If the PC1 is trying to ping to PC2, the source MAC address will be PC1. So it checks the MAC address. What is the MAC address? And as soon as it check the source MAC address, the switch will check its CAM table or a MAC table for the entry. Now it tries to find the entry for this MAC address, for the source MAC address. And if the entry is there, it's good. It will not take any further action for this source MAC. But if the entry doesn't exist, what it will do? If the entry doesn't exist, it will create an entry dynamically. When you try to ping PC1 to PC2, at that time, did you added any entry? This entry which you are seeing over here, this entry which you are seeing over here, this entry which you are seeing over here, did you added it? No, it is dynamically learned. As soon as you try to ping PC1 to PC2, the switch check that from where the source is coming. Okay, the source is PC1. It checked, does it has the entry? It doesn't have an entry. So what it did, it added the PC1, the source MAC address, into its CAM table or into its MAC table. But if in case this entry was already there from before, the first time you ping, the entry was not there. But the second time you ping, the entry is will be there. Why? Because it has learned dynamically. So the second time you try to ping, what it will do, it will enable some timer. That timer we'll discuss later. We'll just forget for now. But you understood now? As soon as the PC1 try to ping to PC2, the switch will check for the source MAC address of the PC1. If it is not there, it will add the entry into the CAM table or a MAC table. Now, when you try to ping PC1 to PC2 at that time, switch was not knowing the MAC address of PC1 or MAC address of PC2, right? Ala is asking stores MAC of interfaces of switch or MAC address from device connected to it on MAC table. Yes, Ala, see, as soon as you try to ping PC1 to PC2, initially switch was not knowing any MAC address of the devices connected to its port. As soon as PC1 send a request, ping request to PC2, so what switch initially does is switch check. okay, fine, this request has come to me. What is the source IP in the frame, in the packet, in the frame, not packet, sorry, it is frame in switching. So it will check the frame, and it will see that, okay, fine, PC1, the source of in this frame is PC1 MAC address. It will store it. As I have shown you the MAC table, now it will store, it will say that, okay, fine, see over here, it will store this entry. It will say that on my port FA0 by 1, I have learned the dynamic MAC address, which is this, and the VLAN is this. This information will be stored in the MAC table now. But initially, what happened, since PC1 doesn't, now PC1 tried to ping to PC2. PC1 doesn't have the MAC address of PC2, right? PC1, this PC doesn't have the MAC address of PC2. Generate an ICMP. What will happen? The ARP request will be generated as soon as the PC1 sends the request to switch, and the ARP request will be generated. How the ARP request is generated, we have learned this, right? Anyone has any questions on ARP request? But let me explain you. What happened? PC1 tries to ping to PC2 via this switch. The PC1 doesn't know the MAC address of PC2, so the ARP request will be generated. Now, when this ARP request hits the put fast Ethernet 0 by 1 of the switch first looks at the source MAC address, which is the PC1 MAC address. Since this switch doesn't have the MAC address of the PC1, the MAC address entry will be added. The very first thing what will happen, the MAC address entry will be added. The MAC address entry of the PC1 will be added. And now this switch will flood the request on all the interfaces within the same VLAN. This switch will flood the request on all the interfaces, all the switch interfaces. Now, if it has 40 interfaces, 48 interfaces, except this, it will accept the interface from where it has learned the MAC address. It will send the request to all. It will flood the request to all the interfaces. When now all the interfaces will received, all the interfaces will receive the request and they will reject it. But PC2 will accept that, and PC2 will generate a reply to PC1. PC2 will generate a reply to PC1 ARP request over here. Okay. So now what will happen? As soon as the switch will check for this entry as well, there is no entry. So switch will flood the packet, will flood the request, and now it will go to PC2. Now you have said that PC1 want to ping to PC2 with the destination IP address. All of other will be rejecting, but the PC2 will see that yes, this is the destination, and over here it will reply back with its MAC address. Now this switch which is over here will be adding one more entry, that is of PC2 and PC2 MAC address, saying that I have learned this MAC address on this specific port, and the communication will be established between PC1 and PC2. Is it clear? Any questions? Any doubt over here? Any questions? Any doubt? See now, PC1 want to ping to PC2. PC1 doesn't know the MAC address of PC2. So what PC1 has said, ping 192.168.1.2. The request come to switch. Switch check the source MAC address and adds the entry in the switch. At the same time, switch doesn't know the MAC address of PC2. So the packet cannot be delivered. As we have learned that end-to-end communication over the internet happens on the MAC address. Now, this switch will flood the traffic. Will flood the request. Once this is flooded, it will go to every devices. Every devices will see that 192.168.1.2 is not my IP. It will not respond, and the request will be rejected. Now the PC2 checks that 192.168.1.2 is my IP address. So this request has come for me. It will reply back. It will create one frame, and over here also it will say that okay, fine, my MAC address is this, and this is my source IP. Every the frame will be created, and again it will be sent back to switch 0. This switch will mark the MAC entry in the table, saying that okay, PC2, from this port I have received the MAC address which is dynamic in nature, and it is dynamic in nature, and it is to a specific VLAN, and this is the MAC address of this switch. So this is how it happens. For everyone it is clear now. Remember, this dynamically learned MAC address, the MAC address which is learned dynamically, are flushed after 5 minutes. Within 5 minutes, it will be flushed out. If there is no communication, if there is no communication between PC1 and PC2, this dynamically learned MAC address will be flushed out after 5 minutes. Now, we will prove this. Now, come over here and go to this switch. What you do is just, if it is enable, and give the same command, show MAC address table dynamic, hit enter. See now, for everyone there is no entry, right? That entry is flushed out because the timer is 5 minutes, the aging timer. Once the switch has learned the MAC address entry dynamically, the aging timer is 5 minutes. After 5 minutes, the entry will be flushed out. Everyone, you can see there is no MAC entry right now in the table. There is no MAC entry. Can you please confirm the chat box? Everyone can see this. There is no MAC entry because that is flushed out after 5 minutes. Please confirm in the chat box. Everyone is able to see this, the same output. Okay. This was something dynamically learned. But remember, there is also something static learning of MAC address. You can bind the MAC address. You can define a static entry of the MAC addresses. You can also statically bind a MAC address to a switch interface. Like let's say for example, PC1 has a specific MAC address. You can bind this MAC address to your switch interface where it is connected, which is fast Ethernet 0 by 1. And once you configure the static address, static learn MAC addresses must never be flushed. It will never flush. If stat if the MAC address is statically bind, it will never flush from the MAC table or the CAM table. Now, if you want to bind the MAC address, how it will work, I will tell you. Do one thing. Just go to this PC1. Go to this PC1 and give the command ipconfig all, and you will find the physical MAC address, right? Just copy this physical MAC address and copy it. Okay. Come to your switch over here. How you will bind statically, that I am showing. Give the command just type config here. Just type config. What is this config and all? I will explain you when we will be doing a proper switching lab. But for now, just type config. Hit enter. Give this command MAC address table static. Paste that copied MAC address over here. Give VLAN 1 and say interface FA 0 by 1 and hit enter. Now press Control C over here, Control C, and the command show MAC address table dynamic. You are not able to see anything, right? Now give the command show MAC address table static. You will see one entry. Everyone has done this. Now, this is how everyone has done this. Please confirm the chat box. Okay, so this is how your MAC address is learned and your aging timer is set. We have seen that how you will be defining the static entries. This is all thing we have discussed. Now, going forward, what we are going to do is frame switching, frame flooding, and ARP request is again what I have shown is not is a basic one, but we have to learn in detail different scenarios where ARP table is learned. So it is again a 1 hour lecture for ARP table itself, which we are going to cover in the next lecture, and we will learn in detail the different scenarios where if there is a switch, how the ARP address will be learned. If there is a router, how the ARP address will learn. Everything will learn in detail. So today we will stop over here and see you in the next lecture.